right, well, I want to thank everyone for joining us today for our program, Boost Your Brain to Support Health and Learning, featuring Dr. Lara Boyd, who will discuss behavioral changes you can make to enhance brain health. I'm delighted to welcome Dr. Boyd. She's a physical therapist, neuroscientist, and distinguished university scholar at the University of British Columbia. She's also a fellow of the Canadian Academy of Health Sciences. Dr. Boyd's an expert in the neurobiology of learning and uses advanced brain imaging approaches to explore how behavior shapes learning, unlearning, and relearning. She's published over 200 scientific papers, and her TEDx talk, After This, Your Brain Will Not Be the Same, has been viewed more than 38 million times. So without further ado, let's welcome Dr. Lara Boyd. I'll turn it over to you.
Thank you, Deidre, and thanks to the staff at Senior Planet who invited me to speak today. It's an honor, and it's nice to, I guess, virtually get to speak with so many of you from all over the country. I'm joining you from rainy Vancouver, British Columbia, so I don't know if we have any other Canadians on the call, but if we do, hi, nice to see you. Welcome. And so today I'm going to try to accomplish, I think, 4 things. I first would like to walk you through some of the brain health conditions that we worry about a lot as we age. And then I want to talk a bit about how our brain changes. And then lastly, finish up with things that we know hurt and things that we know help brain health. So with that said, let's just get right into it. I want to acknowledge my funding sources. The majority of the data that I'll show you today is funded or comes from my research lab, and my funding all comes from public foundations and the federal government here in Canada, as well as the provincial government of British Columbia. So I think this is the big one that we all really worry about the most, I think, with aging. So that's dementia. And I want to just talk a little bit about what are the risk factors for dementia. So our primary risk factor for dementia is actually just age, and there's not a whole lot we can do about that. And so the plot I'm showing you here, these are Canadian data, but it's a similar pattern no matter really where you are in the world. This is from the Alzheimer's Society of Canada, and what you're seeing here on the bottom, this x-axis, are bins of people by age group. So in 5-year increments, so 60 to 64 up to 90 plus. And what you see then are the numbers of people in Canada with dementia at this time, as of 2020, in the dark blue. And then this is what we're really terrified about in public health, is the lighter blue is what we're projected to see in 2050. And so we think these increases are coming based on a couple things, based upon the rapid aging of the population in general and looking at kind of current health patterns and behaviors. And then also kind of projecting out that kind of some of the risk factors that we see now, how they may manifest later. So what we're hoping through talks like this, for example, and other venues, is that we can modify by reducing down these projected numbers by helping people understand what they can do to preserve their brain health. And kind of the last point I would make about this slide is that females are at much higher risk than males for the development of dementia with aging. So that's something that we need to be particularly mindful of as we consider what behaviors we want to engage in. So I would note to you as well, though, that when we think about the risk factors for dementia, an enormous number of them are what we call modifiable. So there are things that you can change. You can change them right now. It doesn't matter at what point in your lifespan you change them. They will have an impact. And in doing so, you reduce your overall risk for dementia with aging. And so if you look across these, we kind of break these into things that we could do in midlife, which would really extend up to probably about age 65. And then if you look at the plot, you can see that then there's risk factors that you can modify later in life that have a huge impact. And so things to think about in midlife would be, education. So, education levels seem to be very protective against dementia. It's never too late to learn anything. So that's definitely something that's easily modifiable. Another big one that lots of us try to ignore is hearing loss. So as we lose hearing, we significantly increase our risk for dementia. So one of the simplest things you can do is have your hearing checked and take action if it is diminished. Having any kind of past head injury is also very impactful for risk factor for dementia. And then there's a few kind of things that I think probably everyone knows, which would be high blood pressure, alcohol misuse, so excessive drinking, and being overweight. As we move into later life, things that are really important would be not smoking, if you are suffering from depression, seeking help and trying to mitigate that. Having a rich social network, which we'll talk about a lot towards the end of the talk, physical inactivity, living someplace with a great degree of air pollution, and diabetes. So the big take-home message here is that we can change a whole lot of things that are going to reduce our risk of developing dementia as we age. So the other thing that is a very significant factor with aging would be stroke. And this is actually my area of research expertise. And so it's something that I worry about a lot. So again, you can see these are data from the federal government in Canada. They would be very similar in the US. So we see that our stroke risk increases with age. So you see that stroke risk is pretty small in our 20s, although not unheard of, and then increases somewhat linearly with life. And with age. Now, there's a bit of a difference here between women and men, or males and females. So males and men show a linear increase in risk of stroke across time, and they have a higher incidence of stroke overall. However, if you look across the entire lifespan, we see out here where I put these two red arrows, time points where now all of a sudden women are having more strokes than men. And this is particularly the case because women tend to live longer than men. So that gives us, lucky us, the opportunity to have more strokes. And so you see as we move into our 80s and then in 85 plus and into our 90s, women will outpace men greatly in terms of the numbers of strokes that they're having. Now, speaking specifically to women and stroke risk, we do see differences between males and females and when we're having stroke. So I already told you that males have steady increases of stroke through the lifespan, and that is kind of what we think of when we think of stroke. We think of it as an older person's disease, but it actually turns out that females don't share that steady increase in stroke risk. Instead, females show that we have these spikes of strokes at 3 points in our lifespan. So the first spike where your risk is high is when you're pregnant. The second spike is when you go through menopause. And then the third spike for women is when we're very old. And so it's much different. And we don't think about young women as having stroke. And so that's something that's really important to understand, that we think that particular to pregnancy and menopause, when we see that female sex hormones, estrogen and progesterone, rapidly change in terms of their concentrations in a woman's body, that this puts us at particular risk for stroke. And that's why we see those in these two other time frames that are much earlier in life than when you might see men having stroke. So again, I want to come back to the risk factors for stroke. And there's really only a few that we can't modify. So the first non-modifiable risk factor would be age. As we get older, we have a higher risk. The second would be sex, and I just showed you why that was the case. The third would be if you have some kind of family history. And then the biggest predictor of who's going to have a stroke is someone who's already had a stroke. So we find that stroke is the best predictor of stroke, and stroke is recurrent. So once someone has a stroke, they often will have a second, a third, a fourth. In terms of modifiable risk factors, there's a whole host of things we can change to try to avoid stroke. So keeping our blood pressure lower, avoiding heart disease, avoiding diabetes or treating diabetes when it does occur, keeping our cholesterol lower, basically never smoking if that's possible, and quitting if you are smoking now. So smoking will increase your risk of stroke by 50%. So it's a huge, huge risk factor. Being overweight, obesity, using any kind of stimulant illegal drug, so cocaine, methamphetamine, those kinds of drugs will spike your blood pressure and can lead to stroke. And in young women, there is a small increase in risk when you take oral contraceptives. Now, typically when you see this pattern, you'll see someone who's taking oral contraceptives who's also smoking. And it may be that it's this combination of things that will increase that risk in particularly young women. But the take-home message here is that your lifestyle can really reduce the risks of having and developing this brain disease. So let's turn then and talk about brain plasticity. So I'll talk a lot about neuroplasticity and what do I mean when I'm discussing this. So basically neuroplasticity just means brain change. I was able to change something in my brain. So whenever you learn something new, you're changing your brain. And that new learning is represented by structural, functional, and chemical changes in your brain. And we're constantly doing this throughout our lifespan. We're really good at it when we're young. You can think of very young children as being just these sponges of learning. But we don't really lose our capacity for learning throughout the lifespan. We maintain it, until the last breath we take, more or less. And in fact, I would point out to you that, you're changing your brain right now just by participating in, this particular programming. Now, I just showed you or told you that brain plasticity supports learning, and we also think it supports recovery after the brain is damaged, that the brain is able to change around that damage, and then that is part of what is supporting recovery. And so part of what people like me do is think about, well, what interventions can we design that will facilitate what we call positive plasticity. So we want our brain to change in positive ways, to make our brain more healthy, to help us be better learners, to kind of ward off diseases and damage. And so those are kind of the things we're going to talk about today. So what can we do to maintain brain health and have positive plasticity? So the last kind of point I want to make about plasticity is that it's highly influenced by your behavior. So we didn't all get up this morning and take a brain plasticity drug, and you're not seeing an ad for it, every other commercial on TV, right? And that's because there's no such thing. And pharmaceutical companies have tried very hard. This would be amazing if we could stimulate learning through some kind of pharmaceutical. That doesn't seem to be the case. What we find is that neuroplasticity is just very, very dependent upon your behavior. And it also is highly variable from person to person. And so you probably know this. It's more easy maybe for you to learn certain kinds of things as compared to others. And that is a reflection of that individuality in neuroplasticity between people. So the last thing to impress upon you is that neuroplasticity can be positive. So you learn something and it's something you were trying to do. You improved your brain health. But neuroplasticity, it can also be negative. Neuroplasticity just means the brain changed, and our brains are changing all the time. And so if we do something that's very negative, we'll also change our brain. So if you have a drug addiction, for example, your brain isn't producing as much neurotransmitter because you're getting it from a drug, and that's neuroplasticity. Chronic pain is an example of neuroplasticity. Moving in a way that hurts your back is an example of neuroplasticity. So your brain's going to change in response to whatever you're doing. So I always say, choose wisely what you're spending your time and your effort and your energy on, because that's going to shape your brain very greatly. And it's going to have the largest influence on your brain, well above and beyond anything else. Okay, so with that in mind, I thought we would start with behaviors that we know hurt the brain, so stimulate negative neuroplasticity. And then we'll finish up by talking about things that we know promote positive plasticity. So I already mentioned this, but I'm going to harp on it a lot. So smoking is kind of the single worst health behavior you could choose to engage in. So I already talked about smoking and its risk of, for example, dementia and stroke. But we also know that smoking, and this is limited to smoking nicotine, by the way, smoking nicotine decreases cognition. And if you look at the effect size, so how much it decreases cognition, smoking cigarettes has a more negative effect on your brain health as compared to if you had high blood pressure and diabetes, which we already know is not good for your brain at all. So it's going to decrease your cognition. We actually see that smokers have smaller brains, so their brain has atrophied, so it's actually shrunk. It's going to change your neurotransmitter concentration. So the way that our brain works is by this highly integrated network of brain cells. And those brain cells communicate by sending small little packages of chemicals that go from one brain cell to the next. And that's how an activation pattern can be transmitted across the brain. Those little chemical packets, they're called neurotransmitter. One of them that's very important for learning is called dopamine. Dopamine is also implicated in Parkinson's disease, so you may be well aware of that already. So we see that smoking actually reduces dopamine concentrations in the brain because you're more apt to then generate dopamine from nicotine. So you're not as easily able to generate what we call endogenous dopamine, so just on your own. And the net effect of that is it's going to reduce your capacity for learning. And then, of course, we've already talked about smoking as being an increased risk for dementia. So the next one to really talk about would be diabetes. So diabetes, as I've already said, increases your risk of both dementia and stroke. It can have very profound effects upon your cognition. When diabetes is uncontrolled, so your blood sugar is very unpredictable. It may be very high, it may be spiking up and down. We see great losses in planning, thinking, what's called executive memory. And one thing that I really want to point out here is that the more uncontrolled blood sugar is, the more significant your brain is actually aging. So we're now able to calculate what we call brain age. And so your brain age could reflect your chronological age. So you're 50 and your brain looks like a 50-year-old. If you're very healthy and you engage in a lot of health behaviors, you may be 50 and your brain age is 45. Conversely, you could be 50 and your brain age could be 55. And so that's what we see with uncontrolled diabetes. So people who are pre-diabetic, so their blood sugar is slightly high, you see that they're already a half a year older in terms of their brain age as compared to their chronological age. And then with increasing amount of blood sugar dysregulation, we see that brain age accelerates even more. So it's such that the most kind of uncontrolled blood sugar with diabetes would add up to almost 5 years of brain aging. So your brain being 5 years older than your chronological age. And that's certainly something that we want to avoid. We want to be pushing our brain age the other direction. So high blood pressure would be kind of our next one. And so I have to harp on this just a little bit. I'm a stroke researcher after all, and so it's something I worry about a lot. So high blood pressure will also increase your risk of stroke and dementia. What it also can do is cause a very specific kind of dementia called vascular cognitive impairment. So people who have very high uncontrolled blood pressure can be actually having very, very small strokes almost constantly throughout the day. So you can be showering these what we call mini strokes, these very, very tiny, tiny strokes. And what will happen is those strokes will, as they begin to accumulate, they will affect your cognition and will lead eventually to clinical dementia. So this is actually a very large source of dementia in the aging population and in people who have uncontrolled high blood pressure. And the damage with high blood pressure is you can be walking around with it and have absolutely no idea that it's taking place. And so it is also possible, we have our typical Alzheimer's type dementia, which I think probably everyone's very familiar with. You can have Alzheimer's type dementia and vascular cognitive impairment at the same time as well. So this vascular cognitive impairment can make your brain function even worse if it's taking place. So it's a really important reason to keep our blood pressure under control. Obviously, high blood pressure increases risk of heart attack. It has a very significant effect on kidneys and can lead to kidney disease. And it can also impair cognition. And so I just put up here kind of the chart of what your blood pressure should look like. So really, even if you're in this stage 1 hypertension, 130 systolic to 80 to 89 diastolic, that is something to keep a real close eye on. If it's persistently high and spiking up higher than that, then you should definitely speak with your physician. And even if you're slightly elevated, you may want to speak with your family doctor about, how to reduce that, whether or not it's time for medications. There's a lot of other ways to reduce blood pressure as well. Exercise, reducing salt, et cetera. And your physician will talk to you about that. But I think it's really important to be mindful that high blood pressure doesn't just, increase your risk of heart attack. It has these other very subtle effects, and many of them may be on your brain health. So I already mentioned this, but I'm going to talk about it a bit more because I'm not sure that everyone's aware of it. And that is hearing loss has a very negative effect on our brain health. So people with uncontrolled hearing loss show increased risk of cognitive decline, dementia, and Alzheimer's. And what we really see is that losing your hearing will accelerate brain atrophy. So it actually leads to your brain shrinking. And that's what's in this picture that's up here in the top corner. So what we see is on the right-hand side, you'll see someone with normal hearing. This is an MRI scan. And what it's showing, imagine if you cut the front of my face off and you were looking straight into my brain. So it's called a frontal view of the brain. And your brain really should look kind of as big and robust as possible. You don't want to kind of have a buff brain. And this is very easy to contrast than someone with significant hearing loss. You can see a large amount of atrophy, so a lot of brain loss around in here. And what we're also showing here are metabolic patterns of activity. And you can see a very different and abnormal metabolic pattern of activity on this hearing loss side. So hearing loss will also speed brain aging. And we know that the very simple action of wearing hearing aids will reduce and can reduce your dementia symptoms by up to 75%. So you can be feeling like maybe you're confused or someone you live with is confused. And it may be that they're not confused, they just can't hear. So they're not tracking what's happening in conversations and in interactions. And so this is a really, really simple and now relatively cost-effective way to really protect your brain health. So the last one I want to talk about before we shift to kind of more positive behaviors would be the effect of chronic stress. So stress is not a bad thing. We all have stress in our lives, and stress is very regulated in our bodies and our brain by this hormone called cortisol. And so cortisol is the reason that all of us woke up this morning. So if you're like me and your alarm clock went off and you were sound asleep, it jolted you awake because you got like this spike of cortisol that kind of, jumped you up out of the bed. Normally, if you've had enough sleep or you don't have to get up particularly early, your body will just release a bit of cortisol. And as that cortisol raises to a certain level, it will wake you up. And so cortisol is really helpful in that it allows and regulates our sleep-wake cycle. A little bit of cortisol or the right amount of cortisol has positive effects on our memory, on immunity, on pain sensitivity. And so cortisol is not really an enemy, but we do think about it as this inverted U, if you will. So if you have too little cortisol, you are difficult to arouse. You have low motivation, you're really sleepy, kind of have trouble getting going. If you have too much cortisol, you're jittery, anxious, you'll see your memory can be impaired. You'll know that feeling of like just being so stressed you can't even think. And it can lead to health issues. So it can raise your blood pressure, it can change your cholesterol levels, lead to weight gain, it can lead to bone density losses, muscle losses. So nothing we really want to have there. So what we want to do is have the right amount of cortisol. Now, we know that when people are chronically stressed for a very long time, we'll see that cortisol levels will elevate and they will stay high and they don't come back down in this kind of normal pattern through the day that we typically see. And so one interesting kind of feature of high levels of cortisol is that it's been shown that this then decreases our capacity for brain plasticity. And we think that happens by cortisol's action on decreasing what we call growth factors or neurotrophic factors in the brain. So these are other chemicals in the brain that make it easier for our brain cells, for our neurons to reorganize themselves. And neurons need to be able to reorganize their connectivity in order to support learning. So if we keep our neurons from being able to reorganize because our growth factors in the brain are low, then we're going to be poorer at learning. And that's what happens when we have persistently high cortisol. And the net result of that is you can actually see changes in key brain regions. So one of them is a memory structure. It's called the hippocampus. It's very important for making new memories and retrieving old memories. And so when the hippocampus is affected by high cortisol, what we see is that it shrinks down. And that's a real manifestation or a real sign that this individual is going to suffer from a poorer ability to learn, and that may be reflected by chronic stress or caused by chronic stress. Okay, so that's enough of the bad news. let's turn around. Let's talk about what we can do. So those are actually things we can avoid. These are things that we want to actually actively undertake, that we can kind of use as tools for brain health. So we're going to manage our stress. You knew I was going to talk about it, exercise. I always say it's the one intervention that is always prescribed. We'll talk about kind of things around the lines of mindfulness, yoga, and gratitude, sleep, and then socialization. Okay, so back to stress. So what will reduce cortisol? What will help you manage your cortisol? And so this is just a combination of a series of, these are all from different studies. But we know that people who meditate, and these are not Buddhist monks, these are just people who engage in regular meditation, that if you engage in a meditation class for as little as 6 weeks, you see significant reductions in cortisol. You also see significant reductions in blood pressure. So this seems to be a very effective method. I would ask people to raise hands if we were in the room together, but I don't know, how many people slept at least 8 hours last night. If you did, then you're a better person than I am. I didn't quite make it last night. I was up kind of late watching basketball games. I love basketball. There's good ones on last night. And they were on kind of latest here on the West Coast. It's been on really late if you were on the East Coast. But if you sleep 8 hours a night, you will decrease your cortisol. So I don't want this, I'm just reading this and thinking it might be confusing. So 6 hours of sleep increases cortisol in the bloodstream by 50%. 8 hours of sleep actually reduces your cortisol. So definitely we see that sleep is playing a role in the regulation of stress. Exercise is an incredibly powerful way to reduce stress. And so what we see is that when we actually exercise, that our cortisol will go up because we did something hard and we were stressed, but then it rebounds and it goes back to a level that was lower than when we started, and it will stay low. And then lastly, there's a nice study I'm going to show you in a minute of children who engaged in a mindfulness class. And what was seen, one of the side effects there was that they had much lower cortisol levels when directly measured at the end of a several month long mindfulness intervention that was run here in the Vancouver schools. So there's a lot of tools here that you could use to try to reduce your stress if you feel like that's a problem. And maybe the easiest one would be just to try to get a little bit more sleep, but there's some other things in here as well. Okay, you're gonna have to suffer through me talking about one of my favorite topics, and that's exercise and brain plasticity. So we know that exercise has an incredibly powerful effect on our bodies, and probably an equally, if maybe I might argue, more powerful effect on our brains. So within our brain, when we exercise, we know that we see more blood flowing to the brain. We see that more blood vessels are formed. So you have more complicated vasculature in your brain, and that allows more blood flow. We see that both types of brain structure that we have, both white and gray matter, increase. So it makes your brain more buff, if you will. It makes it bigger. We see that brain cells called neurons and their connections called synapses both increase. We see more of those growth factors that I was talking about that enable plasticity. And we see more neurotransmitter concentrate. So those are those chemicals that go between the cells and allow them to activate one another. The net effect at kind of a neurobiological level of exercise are all of these incredibly positive things. Now, this is just a little example, and this is a neuron. This is actually what a neuron looks like, or a brain cell. This one was taken from a mouse who was not allowed to exercise, was kept in a more confined area where they couldn't exercise. And the one on the right is taken from a mouse who was allowed to run on a wheel. Mice actually quite like running on wheels. And it's just a nice snapshot, and it's very visually obvious that the mouse who exercised was able to create a much more complicated neuron, many more connections, those are those branches, so more capacity to influence the neurons around them as compared to the mouse that was not exercising. So it gives you kind of a little bit of a visual of how some of those other beneficial things happen. So another thing that we know exercise does, and this is some work from one of my past graduate students, is that even a single session of aerobic exercise, so exercise, where you're breathing hard, this was actually cycling on a stationary bike, significantly increases those trophic factors, those growth factors that allow the brain to be more neuroplastic. So the one we were measuring here was called brain-derived neurotrophic factor, or BDNF. And so we see this is just in a group of people. This is their BDNF before they exercise. This is their BDNF after. And so you see this increase in the growth factors in your brain that are going to hopefully facilitate learning. We've also done a lot of work in my laboratory looking at whether or not different kinds of exercise can facilitate learning, so can make us better learners. So I'm going to walk you through this experiment that we did. And I hope this slide isn't too complicated. I think I can unpack it for you. So in this experiment, we had people exercise and then practice a new motor task. So the task they were doing was they were trying to track a target as it moved through space. And they were trying to be as accurate and accurate as fast as possible in tracking this target. Now, there was a control condition in the target. So sometimes this target was following a repeating pattern. When you make a repeating pattern over and over again, you can learn it. And sometimes the target that people were trying to track was following a random pattern. So they couldn't predict where it was. They were just trying to react to where they thought it was going to go. So we then had a group who did this, who exercised, and a group who rested. They didn't exercise in association with the practice. In fact, we showed them some videos just to control their attentions. They were watching Planet Earth videos. We've got Planet Earth video group, and we've got an exercise group. Now, the exercise group in this particular study, they did what we call high intensity interval training. So these people engaged in 9 minutes of exercise. So they did three-minute long bouts of exercise. And each of those 3-minute long bouts was nearly as hard as they could exercise. They were on a stationary bike. We tested them in advance to see how hard they could pedal. And then we asked them to work at 80% of that maximal ability for 3 minutes. And they took a 3-minute break. And then they did 80% of their maximal ability pedaling for 3 minutes, took a 3-minute break, and then one last round of exercise. We looked at the effect of that exercise then on their ability to learn these repeated and random sequences. And what's really interesting is that within a single session, so they exercised, we practiced, and then we tested to see if they learned anything. Within a single session, we see absolutely no effective exercise, 0. So if you stop the experiment after one session, you would say, well, exercise doesn't have any effect on learning. Lucky for us, we knew better. And so we had these people come back a second day. This is day 2 here on the right side. And on that second day, people didn't exercise. They just performed the task. So we said, show us how well you can do that task. And we compared it to how they did the day before. And so I just want to point your attention to the repeated sequence is here. This is what they were supposed to learn. In gray is the resting group, and in black is the exercising group. And a higher number on this learning task is better. So what we found is that compared to the day before, we see significant increases in learning that just happened overnight. These people didn't exercise overnight. They didn't practice overnight. And so this benefit of exercise seems to be on the ability to make a lasting memory. And so we call that memory consolidation. So think about when you're learning something and just starting to practice it, and it's very kind of fragile. You kind of can do it and then you mess it up and then you can kind of do it. That's what we call acquisition. And that's when our brain is trying to make a memory. And we know that for that memory to be a robust memory that we can call on later, that it takes time. It probably also takes sleep. That's why we wait 24 hours here. So what we think that exercise did was it increased our ability to take that short-term fragile memory and make it into a long-term lasting memory. And that's what's really shown here. What else is interesting here is that is very specific to what was trying to be learned, to the repeated sequence of movements. We don't see it in the random movements. So this is a very specific action on our ability to learn, and then on basically brain health, because we know we've made new connections to support that learning. So I want to just impress upon you that there's now just a huge literature in this area. And there are a zillion different ways that you can exercise to support your brain health and promote learning. So we tend to use cycling in my lab because it's easy to have a cycle in my lab. And we do this with stroke patients, and we don't want anyone to fall. But work by my colleague, Teresa Louis-Ambrose, has shown that weightlifting, so anaerobic exercise, is really, really beneficial for brain health. It actually seems to be extra beneficial in women. We seem to have a bigger response to weightlifting than men do, not in terms of like, getting buff, but in terms of our brain health. Other work has shown that walking is an outstanding way to get exercise to stimulate your brain health. And there are even things, like gardening. I mean, if you enjoy doing it, housework, anything that's going to get your blood, your heart rate up a little bit and your blood moving a little bit through your body seems to have a very positive effect on your brain. Okay, I want to talk really quickly just about a couple things that we know about mindfulness, yoga, these kinds of interventions. So these are data from a study that was run here in Vancouver. These are actually data from children, but I show them to you because they're really quite remarkable. And we have a program that runs here in Vancouver. It may run in some of your school districts. It's very popular in Canada and the US. It's called Mind Up. And the idea here is to just give kids in the classroom a brain break. So to just allow them to de-stress and refocus their attention for a few moments each day. And so the way Mind Up works is that children are asked, or you can do it as well. You can Google search it quite easily and find the program. You're just asked to take 3 minutes and to just relax your mind, to kind of just concentrate on how you're feeling at the moment and be okay with that. And just take a second. So you're not on a screen, you're not doing any work, you're not talking to anyone. You can close your eyes if you want to, you're supposed to, but I had twin daughters who were both in this program because it's in the school districts here, and one of them said it made her uncomfortable to close her eyes. So she just looked down. That seems to work too. Anyway, these kids, compared to kids who weren't in Mind Up, engaged in this for across 3 months of the school year. They did this 3-minute session daily for those amounts of times, and guided by a teacher. And at the end of the 3 months, these different things were tested. And basically what you find is the Mind Up group is in the dark gray, and up is kind of improvements. And the comparison no mindfulness group is in the light gray. And you find that these kids rate higher on empathy, on perspective taking, which is taking someone else's perspective, seeing how someone else might feel. They were more optimistic. They had better emotional control, which I'm sure the teachers were happy for. They thought more highly of their school. They had a higher school self-concept. They had lower depressive symptoms. They were better able to be mindful, which is good because they practiced it. And then also tested with social responsibility, and that didn't change. But what you do see is this huge number of benefits from just taking a moment, kind of out of the day and letting your brain relax. And so, like, why? I mean, I've thought about this a lot. What do we think is happening in the brain? So we don't entirely know what's going on, but we do know that when we're at rest, our brain reverts to kind of a basic excitability state. So our brain is actually never silent. Contrary to what our moms all told us, turn your brain on, you're only using 10% of your brain. None of that is true. Our brain is always on, it's always active. It's even active when we're asleep. It goes to when we're sitting and we are seemingly doing nothing, our brain goes to a mode called default mode. It's very stereotypic. You can see this in babies and adults. You can even see it after the brain is damaged. And it turns out that a lot of thinking is now coming to the conclusion that going into default mode is actually good for our brains. It's a reset, if you will. It gives you a moment to kind of reset your neural activity. And we think that that's what's happening during mindfulness, and actually maybe also during yoga. That's giving our brain just a moment to reset. And we don't do that very much in our daily lives anymore, right? Because anytime that we have a moment free, what do? We pick up this damn thing and we start scrolling around. Anymore, I read the news and then I feel depressed, and I should just throw it out the window and give myself 3 minutes to just be. And that's what we think has happened here. Just as an aside, there's also some work being done by my colleagues here. She's looking into spontaneous creativity. And they find a very powerful link between spontaneous creativity and being in the default mode. So having let your mind wander a bit may actually be really, really good for your brain health. We've tested this kind of more experimentally in the MRI. And so what we did is we are able to induce different emotional states with people by showing videos. So if you were at my talk last year, I showed this video. It's a baby laughing uproariously. It's the happiest thing you'll ever see. So we were able to kind of test people's brain activity when they were really happy. We then showed a very angry video. We also showed a video that was very upsetting. It was a clip from Schindler's List. And we're able then to map kind of what the brain is looking at during these states. So the manipulation we were doing here was we were testing 3 groups of people. So we were looking at people who did a lot of yoga, what we call elite yogis. I'm in Vancouver. People do a lot of yoga here. These are people who had 5,000 hours of yoga practice. Crazy. That's a lot. We looked at people who were recreational yogis. They, go to a class 2 to 3 times a week, and they have done for a while. And then we compared everybody to runners, recreational athletes. I'm a runner. These were all my buddies. And we looked to see which brain was better able to adapt to these different emotional states, depending upon what you were doing in your daily life. And one of the real measures of this is heart rate variability. So the more actually variable your heart is, the more healthy. Heart rates that are very stable, it means your heart's having trouble adjusting to different things. So firstly, we found no difference between the elite yoga people and the regular, recreational yoga people. So we put them in one group. And when you put that group together, they are significantly better at regulating their heart rate as compared to the runners, which made me sad. And was a real, I should do yoga probably. I'm not very good at yoga, so I don't really enjoy it, but I should do more. So firstly, we see better heart rate variability in the people who are doing yoga. And we also saw a very different pattern of brain activity. So when we showed the people who did yoga, these really emotional videos, and we compared that to the runners, what we found was that the runners would react, especially the upsetting video, the Schindler's List one. The runners had a strong reaction. We saw that in their amygdala, which is a kind of an old brain region that we know is very important for kind of stress, for fight versus flight. And we see it also regulated in post-traumatic stress. The yoga practitioners were more just kind of observers, if you will. Their amygdala didn't turn on. It was like they observed it, but they weren't like gutted by it. And so that suggests a more adaptive kind of response. So 2 last points, and I see I need to speed up a bit. The next one that we know is really important for brain health is sleep. And so all mammals sleep, and it's not entirely clear why. And yes, these are my children. I have twins. They're 19 now, but this is when they were still darling and yes, and liked me a lot more. I think they still kind of like me, but anyway, we all sleep. We don't know why. It's a really interesting question why we sleep, because it's a very vulnerable time. If you think evolutionarily, you really wouldn't want to go to sleep and, potentially be eaten by a tiger. And that's probably why a lot of animals sleep in trees, for example. So why do we sleep? Well, one idea is that it contributes to the process of brain plasticity and memory. And this is called sleep-dependent memory processing. So we now know pretty clearly that in order to make a new memory, we have to sleep. And by preventing sleep, we can actually induce psychosis in patients. In fact, it's a torture technique. I want to circle back to cortisol a little bit and remind you that the 2 hormones that regulate our sleep and our stress, they compete with one another. So when cortisol is high, our melatonin is low and we're awake. And when melatonin becomes high and cortisol goes low, we go to sleep. And that naturally we cycle through these patterns through the day. So, early in the morning, you'll see cortisol spikes. It's in blue here. It should be highest first thing in the morning and should decrease through the day. As it gets to be dark in the evening, our melatonin will rise, and that makes us sleepy, and then it spikes and comes back down. And this is kind of the normal process that we should be going through. And really interestingly, this process is entirely regulated by light. So we have a dedicated circuit in our brain that when we see light, it inhibits the circuit and it prevents the expression of melatonin. And so we stay awake. And then when the light is turned off, melatonin can be expressed in the brain, cortisol goes down, and we want to go to sleep. And so this is why it's so important for your sleep that you turn down the lights or turn off the lights, get away from screens, and allow this kind of natural process to take place. Now, I just want to point out, because I think someone will ask, you can take melatonin to try to facilitate this process. It's not as effective because it's difficult to get it into the brain itself. So it's in your blood, but we have this thing called a blood-brain barrier that tends to keep things out of the brain. And so much better is to have a more normal kind of sleep-wake cycle if you can. So we know that when we're asleep, that we'll see patterns of brain activity that reemerge that are similar to when we were awake. And there's work that's been done where there's scan in the MRI scanner, people's brain activity when they're awake, and then people will sleep all night in the scanner, and they'll continue to look at their brain activity. And what you see is a reemergence. And so we think that people were almost practicing things in the night in our brain that we did during the day. And that may be part of why it's so important for both brain health and for learning. So just really quickly, how much sleep do you need? More than you think. I mean, it would be a dream if I could get away on 5 hours a night. I cannot, I'm a disaster. So if you look, at young adults, they really need 7 to 9 hours of sleep. Up to about age 65, you're still at about 7 or 9. As we get older, we do need a little bit less sleep. However, our sleep patterns will change with aging. And so we find that REM sleep the type of sleep, one of the phases of sleep is less with aging. And so you may need to have more overall hours to get enough. Someone will ask about naps. Naps are great. They have a similar effect. The trick with naps is to not have so many of them or such long ones that then you can't sleep at nighttime. Okay, and the last one to just wrap up by talking about social connections. So really interestingly, social connections are incredibly beneficial for brain health. So we know they stimulate attention and memory. They help us manage stress, anxiety, and depression. They reinforce other healthy habits. We all have a group that gets us out and makes us behave. I've been running with the same group at Saturday morning at 7 a.m. for, 20 years. The best part is coffee after the run. I would never do it unless I was meeting my friends. They get me out the door. And that's the whole point of that socialization. It's the most fun thing I do all week. We also think that social connections may actually reduce brain aging by the production of some trophic factors called glucocorticoids. So how do we know that social connections are so important? So we have data, and you may have seen the Netflix special on blue zones, or you may be aware of this, but there are these special areas around the world where people live incredibly long. So these blue zones are areas of the world where people live to be 100. There's 5 of them that are very well studied: Loma Linda, California, Nicoya, Costa Rica, Sardinia, Italy, Ikara, Greece, and Okinawa, Japan. Now, what is going on in these blue zones? Like, what's special about them? So when you look at what's happening in these blue zones, you find that these are kind of the key elements. So people live close to their families. They have rich social connections. They don't smoke. They're semi-vegetarian. They're not totally vegetarian, but they don't eat a lot of meat. And they have nearly constant moderate physical activity. So this seems to be the recipe that these kind of blue zones are suggesting to us. And if you look carefully across the 3 big ones, and you look kind of what do they have in common? Because some of them are a little different. So of course, in Sardinia, they're drinking wine, and that doesn't seem to be a negative thing. And in Okinawa in Japan, they eat a lot of turmeric. What's the key? The key ingredients here, though, seem to boil down to family, not smoking, a mostly plant-based diet, lots of physical activity, social engagement, and they eat a lot of beans. So go home and have legumes or have them for lunch. But this seems to be the big kind of piece of what is going to lead to brain health and longevity. Okay, so just to wrap up really quickly then, I want to remind you that most of the risk factors associated with common diseases of aging are modifiable, so you can change them. Behavior is the largest stimulant of neuroplastic change and brain health. And then you can enhance longevity and brain health kind of through the things we've talked about. So keep stress down, exercise, enjoy those social connections, never smoke, stop if you can. And then I did not talk about diet because I don't have any research that's my own in that area. But we do know from the Blue Zone data that, moving towards a plant-based diet when you can and as you can seems to be an important piece of that longevity. So well, thank you all for listening. It's a beautiful view of where I work and live and play, and it's actually raining today, but it does look like this sometimes in the summer. So I'm happy to answer your questions before you all head off to your days.
Thank you so much, Dr. Boyd. And I'm guessing there's a number of folks here who joined for your talk last year, and myself being one of them. I learned a lot, and so it's helpful to hear some of the same things again and learn some new things as well. Before we jump into the Q&A, I'm going to share a couple of Senior Planet resources in the chat, including the lecture we'll have right after this on digital tools for brain health, and then a fun quiz and a place where you can connect socially online on Senior Planet community around the topic of brain health. But we do have quite a few questions. We'll try to get to as many as we can. From earlier in the presentation, can you reiterate why there's a greater likelihood for females to get dementia?
Oh, thank you for that. I didn't discuss it. We think it's related back to female sex hormones, so estrogen. So there has been work suggesting that, for example, taking hormone replacement therapy in menopause is neuroprotective and helps protect against dementia. So that seems to be one thing that's being pursued. As all of you, or all the women on the call, I'm sure, are very aware that whether or not you take hormone replacement therapy has been very contentious. The study that suggested we shouldn't take it has now been found to have a number of major flaws in it. And so the clinical suggestion right now is that it's important to continue with estrogens as long as you can. So that's one big reason. The second big reason is women live longer, so we just have more life to get demented. And so your risk of dementia doubles every decade after the age of 60. And so, if women are living later into their 80s and then into their 90s, it's just more opportunity.
Interesting, thank you. And is dementia inheritable?
There is one kind of familial Alzheimer's that's inheritable. It's very rare, and if you had it, you would know. So, because everyone in your family, everyone has Alzheimer's dementia by about age 40. So there is a gene that is related to dementia. It's called APOE4. So you might have done a genetic test and you might have found that you have that genetic, it's a trait. But I want to impress upon you that having APOE4 as one of your genes is not predictive of dementia. So it seems to be a combination of having a genetic predisposition and then environmental factors turning on or turning up that gene. So none of this is predictive, and that's why genetics wasn't listed as a non-modifiable risk factor, because it can be changed.
And you talked quite a bit about chronic stress, but could you describe a little bit more about what chronic stress might look like for someone? You talked about it affecting the cortisol. Is there a way that we could measure our own cortisol?
Yeah, so there's not an over-the-counter test to measure cortisol, but it's really easy actually to measure. We measure it in people's saliva, and it's quite simple to look at. You could do a stress scale. There's a number of these that you could Google search and find one to kind of index your stress, or you can kind of do a self-check, like how stressed am I, and see if you can just kind of gauge it that way. But yeah, so chronic stress would be this idea that you're stressed, and we all get stressed, but that stress is staying high for a longer period of time. So for weeks and months and maybe even longer. And that's when you start to see kind of these more really pernicious effects start to take place, is when it's high and it stays high for a long time.
All right, next couple of questions are around sleep. What is the role of sleep apnea in dementia?
Yes, I didn't talk about that, but it has a very significant role. So sleep apnea has a significant role in dementia and also in stroke. It's a predictive factor, a risk factor for both. So if you do think you're suffering from sleep apnea, or often where this is diagnosed is your partner notices that you are either snoring really loudly, or it sounds like then you stop breathing in the night, and that's what apnea is. So you have these bouts where you actually are not breathing anymore. You really need to have a sleep study and then be treated by an appropriate specialist, because that is a significant risk factor.
And I've heard from my mother's experience, actually, the way that sleep studies are done have changed. So if you're like her and we're very hesitant to get a sleep study done because you had a vision of having to stay in this kind of maybe clinical or very creepy room, would recommend talking to your doctor about what different options there are available to you now, because I know some of those technologies have changed.
Yes, definitely.
And you did address this one, but I want to call it out because there were quite a few questions about napping in the chat. So cortisol and sleep, is it okay to nap to get to that 8 hours of sleep?
It is okay. And I'm impressed at you all that can nap. I can't nap. It's terrible. Yes, napping is fine. The trick is not to nap so much that you can't sleep all night. So everyone has to kind of gauge where that is, but taking a nap during the day is perfectly acceptable. It's very interesting. It also is helpful for memory consolidation, so it facilitates learning. So yes, if you can do it and still sleep at night, nap away.
Cool. All right, and our last couple of questions in these few minutes here are on exercise. So some questions around how intense exercise needs to be to get the benefits. Would stretching regularly, for example, help?
Right. That's a really good question. I wish we had a better formula for it. So, my studies have all been on really high intensity exercise because we can do it quickly in the lab. You don't actually have to do that. We know they're incredibly beneficial, but you can, the exercise guidelines are, 30 minutes a day, 30 minutes 3 times a week of moderate intensity exercise. That's walking. I actually don't think that's quite enough. I would prefer to see people doing, 30 minutes walking a day, 5 and 6 days a week, if they're able to do that. In terms of stretching, it's probably not getting your heart rate up enough to have the exercise benefits. However, you may be getting those other kind of mindfulness, yoga related benefits where you're just able to feel your body and relax. You're not on a screen, all of that kind of stuff. So you're going to get a benefit. It's just going to be a different one, but it's probably not a surrogate for aerobic or anaerobic exercise.
Awesome, very helpful. Thank you. And this will be a shameless plug if you've never tried out Senior Planet's fitness programming. We've got a really wide variety, some mindfulness, meditation, yoga, up to things like Fit Fusion that have a higher intensity. So try a few things out. We've got a Friday afternoon dance party in an hour from now. If you want to try something really fun, hear some good music, see some fun dances. It's really a blast. So I do want to make sure we end this on time because I know a couple of people are going to be joining us for our upcoming lecture on digital tools for brain health. But I want to give a big thank you to Dr. Boyd. This has been incredibly helpful. There's a ton of comments in the chat about how valuable this was.